in room 2 with John Benke, where we'll be talking about digital twins, why they're more relevant than ever, and the issues around them. So John, apologies again for the delay just now. Now, to kick us off, can you give us a quick overview of InfoComm and what are the key value propositions of digital twins?
Sure. InfoComm has been around. We just celebrated our 50th year anniversary late last year. Historically, it's kind of known as I mentioned, I think earlier, instrumentation company with gauges, a tremendous amount of sensors, RGAs, leak checkers, things like that. It's really migrating to be more of a fab-wide smart manufacturing solution provider. In my particular group, the IMS group, Intelligent Manufacturing Systems, which is the software part of InfoComm. We have two groups, a FabGuard group, which is basically FDC, APC. Think of it as tool smart manufacturing, tool-centric, process-centric. And then we have my product line, which is the FPS product line, which is the group that works on the entire factory, integrates the entire factory for things like factory scheduling, optimization, in general, smart integration of all the disparate data sources. And so InfoComm is investing very heavily in being able to come in and provide, really with the absence of an MES, almost everything else that you need to have a smart solution for a factory of any size. So thank you.
So InfoComm has been around for decades. So how long ago did FPS come about?
Oh, great question. Sorry. So FPS is actually by itself about 13 years old, but we were acquired we were an independent company out of the United States, based in Austin, Texas, where I'm speaking to you from. And it was a relatively small firm that was really focused on scheduling and smart manufacturing before it was called smart, and kind of a leader in that space. And then InfoComm purchased us in October of 2018. And it's really been great for us because we're able to go global now. Before we didn't have a global footprint, whereas InfoComm has a large office in Singapore. Darren Lee leads our SEA team. It's a very large office, one of the largest offices InfoComm has, although InfoComm is a global company. So we're very, very excited to be part of InfoComm, and thank you very much for asking. Yeah.
So it sounds like this convergence of these two companies, right, is almost like, if you think about it, it's the evolution of the whole industry, right? This came at the right time, where it's at the cusp of this whole movement towards smart manufacturing, and then the capabilities with AI and data analytics and all that all just came in around that time.
You are absolutely correct. I mean, you could not be more correct. I mean, this is one of these things where people say, well, what is I4O or smart manufacturing? And the reality is, it's this continuous improvement activity we've done for the last, well, many of us 30 years. But now with this incredible low cost compute, memory, and really sensorization, you cannot forget the sensorization aspect, which is largely having more information about the tool and process directly. And that's one of the things that InfoComm does, because they've always made sensors, hardware. And I think, credit to the executive team, they realized, well, we need to integrate across the entire factory. And so I think that's what's the difference between successful companies today, are those that are leveraging software in their product lines. And yes, you are correct. It's really integrating with other systems. I mentioned earlier in our earlier talk, any solution we do, more than half of the things we're connecting have nothing to do with InfoComm. There are other system solution providers that you're connecting.
So I guess I asked you this to set you up, because I know you have a deck of slides to share with us. Yep. So maybe it's time now to bring it up, because I want to ask you, you have a deck in one slide in your deck on the rationale for semi-smart manufacturing. I just wondered, how well have these rationales for semi-smart manufacturing stood up to the changed operating landscape in our current times?
That's a great question. I think you're referring to this slide here.
Yep.
Okay. So it turns out that it's, first of all, let me give you the audience a little background on the slide. Just, it's a great question because you've seen it, but let me help the people understand it. So this was done outside by an Institute on Smart Manufacturing, and they just tried to compare the rate of improvement under some of these key areas of productivity, and compare the last 25 years rate of improvement to what is being anticipated and realized under the SMART envelope. And quite frankly, it's somewhat amazing if you take a look at the fact that we're talking about a 13x improvement in on-time delivery, the rate of improvement, 7x in overall productivity, 12x in CapEx and inventory. And the reality is we're actually seeing that. I mean, that's the thing, that there's a lot of disbelief. It's kind of like, oh, is this marketing? You know, is this some consulting firm? But the truth is this digitization, and particularly if you do it in concert with a high resolution digital twin, is completely transformative compared to what we've been trying to do. If you go back in time, lean, continuous improvement, all the things we've done over the last 15 to 20 years, there's no comparison as opposed to what's happening in smart manufacturing today. And so the good news is it's getting a lot of press. The capabilities exist. The bad news is, like you mentioned on the talk, it's not being widely adopted, unfortunately.
So any guesses, percentage-wise, in reality, how many people are actually doing this, or is a long way to go, I reckon?
So there's an interesting question there, right? So first of all, you get into a little academics here, sorry, a tutorial. So what is smart manufacturing, right? You know, and it's really important to understand that most things that a marketing person tell you is smart manufacturing really isn't. It just helps them sell their product, okay? If you go back to the folks that really originated this, it's all about the ability, and this is a good definition, it's really is manufacturing systems that respond in real time to meet changing demands and conditions, okay? Or another definition is pretty good, is digital twins assist people and machines in the execution of the task. Okay, but it turns out many people think because they have huge databases that they have a smart factory. That's not a smart factory. You know, that's a data-rich environment, all right? And those are completely and totally different, all right? So there is this misnomer that the semi-industry in general is, you know, leading the world in smart manufacturing. I would argue from a deployer perspective that it's lulled to believe that, but many cases they're not really a smart factory, they're a data-rich environment. And so having said that, I want to do that precursor. Then you say, well, how many people are really doing it, right? And I think the answer there is probably 15%. I mean, it's just not very many. It's just one.
Or worldwide? 15.
Worldwide. I mean, it's just, you know, and obviously that's driven by the fact that many of the large number of factories are not huge. You know, they're at small to medium size. But it's just something where the leaders of the industry, or the thought leaders, or the ones with strongly driven managers or strong industrial engineering leaders, are taking charge, and they're becoming far more competitive, and their you know, their companies are benefiting. So we see right now it pivoting where we think people are, somewhat because of COVID, are now realizing the benefits, because the companies we work with that have already been doing this for 5 years were much, much better prepared for COVID than those that never started.
Yeah, I can imagine.
Yeah, huge difference.
But I guess like there's a gap still, and the gap is still driven by cost, right? And unfortunately, right now, everyone's margins are kind of squeezed tight, and you know, cost also perennial concern. So when you think about adopting digital twins, they'll first of all think about, oh my God, it's going to cost me like X amount or whatnot. I think we had a conversation before. You want to dispel that, didn't you? Because you.
Oh, yeah, it's really a problem. I mean, it's generated by solution providers or basically, you know, people that are approaching factories that really attack it from the big data side and try to suggest to a factory that they need to effectively replace everything they have to begin. There's nothing that could be further from the truth. Okay, don't get me wrong. If you don't have an MES, you know, that's a different situation. But everybody on the call here has an MES. Okay. I can tell you that we've worked with 13 different MESs, right? And most people probably couldn't name 3, you know? And so the reality is that you don't need to replace your entire infrastructure. You need to integrate your existing infrastructure, identify the gaps. Typically, we see gaps in that people don't have good location tracking. If you make a digital twin, it turns out you need to basically digitally effectively know everything about the factory, which means what can run where, what the tool state is of every tool in the factory, and where everything is. This is not really that complicated. But so that means many factories have to add location tracking. Again, not very expensive anymore like it was. I will tell you the other big gap that we see is tool state information. To digitally create a digital twin, you need to know, is the tool up? Is it down? Pretty easy. Is it a lot loaded on the tool? Is the lot started running? Has the lot ended? And has it been picked up? 4 states, okay? Turns out if you don't have a SexGem connection on all your tools, and some legacy factories do not, or if you're in a back end, some of them don't have the same standards. There are a number of great companies today that for a relatively low cost can interface with your historical tool and create just that data, put it in your MES, and once you've got that, a company like us, and I'm sure there are others, can come in and just aggregate all this data and transform your factory and get you 25% more productivity literally overnight. I mean, it's not as hard as one would normally, I guess you could say, expect if you're not in the business.
Mhm. And then, of course, but we've been talking mainly about the technology side of things. There's also the human side of it, right? I mean, you got like the mindset, maybe the skills and whatnot. I don't know. That's I guess is also a key part to this whole equation of who is ready for adopting. Right. So apart from like the big guys you mentioned earlier, even a small guy, a small manufacturer could be ready if they have the right mindset, right?
No, I mean, you literally hit it right on the head. I mean, I always tell people, and I try to be polite and honest with all potential clients or customers, is that, the amount of time it's going to take to do a project with you and whether it's successful or not has nothing to do with me. It has everything to do with you. That's not 100% true, but it's mostly true. Because when we look at all the projects we've done, those that are super successful have a strong leader. They have a believer. They understand you're making a complete and total change in approach and methodology, and they support that. And they're there to help support the transition at everything from an operator level to a supervisor level to an IT organization to a planning organization. So if you have the right mindset, things go very well. If you don't, and you've got an IE guy that is excited about it, but the rest of the company is like, oh, this is a fad that'll go away, you've got a long road ahead of you that's extremely painful, and really it's unfortunate. So yeah, you're right. The single biggest determinant today, even I would argue more so than the budget, is the leadership of the particular factory. That's been our experience.
This might be a bit of a left field question because we didn't really talk about this, but this just came to me because we're talking about mindset, right? We tend to associate it with the younger crowd, so to speak. I just wondered for the semicon industry, is there a sense that like it tends to be, what's the average age range for people working in the industry?
Wow, that is such a great question, though. It's certainly unprepared. I mean, we used to joke at SEMICON West, which is the one in North America, in San Francisco, that every year the median age of the attendees went up 1 year, which was basically implied it was an aging community, okay? And I've been in the industry for 35 years, literally, okay? And so, but what's interesting is we're seeing a new set of folks coming in, some of our very best client leads, the guys that run these factories, director level, manager level of industrial engineering organizations, are in their early 30s. They're just super excited people. They're very bright, either data scientists or industrial engineering or whatever. And so I would say that the industry is in a transition. Of course, that's driving a lot in the maintenance area and other places about things like, intelligent learning and all those kinds of ML and other systems to aggregate the knowledge of the, I hate to call them legacy employee, but the employee that's retiring, I don't know if that's the right term. But I would say that the industry is in a transformation right now, where we're and I'm looking to retire in 10 years. That's not too fast, but the truth is we're making room, I think, for this next digital generation, which I think is going to be critical to the acceleration of the transformation, because we really enjoy working with all levels, but we really enjoy working with kind of the newer generation at the working level.
So I guess the whole data piece coming in the last decade or so with data science getting hot and sexy, and coming into this industry, it made the whole industry sexier, I guess, in a way.
Well, I think it attracted a different group of people, right? Yeah. So if you go back in Semi's history, and I've done everything from R&D, process R&D, everything you can think of in Semi, In the past, it was, you know, the chemie or, you know, the physicist or, you know, EE, you know, generally speaking around the device physics and the design, right? So
Yeah.
more and more of that is becoming automated through EDA tools and other things. And we're not here to talk about that today. But the industrial engineering aspect, which was really candidly almost ignored for the first 30 years of the semiconductor industry, has now become so exciting. And it's
Right.
become, and because of the fact that we are such a data-rich environment, these data scientists are saying, I want to go play in the backyard that has a bunch of toys, you know? And so I think we're really benefiting from the fact that we have invested so heavily, largely in connectivity and in data. We're just now investing more heavily in sensors and in what's called predicting. This chart that I have up here today is one with the smart manufacturing. I'm the co-chair of the North American Semi Smart Manufacturing Committee, and that's the SEMI is the big group, of course, for all our industry. And this is the way we try to describe smart manufacturing. You know, at the top it says ROI, because why would you do anything if it doesn't make money? That's pretty obvious. But what's interesting is we break it down that really is smart is about connecting, sensing. You have to have information, and sensing could be as simple as I said, tool state data. But it also is all these different advanced sensors that are now being deployed, so you know more about the process tool. Connecting is a big deal. The digital twin's in the middle. We're here to talk about that today. It's very important to know that a digital twin is not a database. It's a smart learning representation of your factory. It is nested inside of it, so many models, et cetera. It has a model of every single tool you have. It has the ability to adapt and learn from historical events to be able to predict the future. And then the right side is the only real ROI part, which is when you take all the information that's housed in the digital twin, which is largely ones and zeros, and you turn them into predicting applications. And so it's kind of helpful to just educate the world on the fact that you really need all three, but they don't all have to be done at the same time. So, you know, that's important.
Right, yeah. Okay. Actually, John, maybe we talked a little bit about talent in this sector earlier. So there's a question actually from one. Yeah, so he's asking about, well, he said demand is actually increasing for engineers in the sector, but actually companies are struggling to find them. So do you have any strategies or advice on how?
That's a good question.
Yeah, how
so I can tell you what we do typically. So we don't have enough staff to just like, you know, hire someone for you, okay? We do sometimes interview with you. So if we're working with a client, we'll say, you know what, we do an assessment, here's what you have. You probably could use somebody of this skill type. And one of my guys will be on the interview panel with you, and we'll tell you where we think those people are, okay? You know, schools or certain curriculum, whatever. But probably the thing we do more often than that is we identify somebody within the existing organization, and we basically call it train to trainer, right? So we find somebody that has a pretty good aptitude that we can basically, throughout a project, take from maybe this level to that level. You know, we just take that individual. It's kind of like going to on-the-job training, very intensive, kind of like a military training would be, you know. And we bring them from their current status to significantly higher, and then that person becomes more or less, think of it as our single point of contact going forward, but at the same time, he or she becomes an expert in smart manufacturing. And we can take, I've never been to a factory that doesn't have somebody that we don't find within, you know, probably the first 2 or 3 meetings that you can just tell by their interest level, their intellect, and their educational background has the background to be able to transform into that. And then we largely try to have them become the trainer of the next generation, you know, the new college grad, et cetera. That seems to work well for us because we do try to deploy a solution that's a standalone. So our model is to dramatically reduce the number of subject matter experts you need to hire by embedding the intelligence in the software and then largely working with you on what we would call a smart user configuration expert. And then we work with those people. We have meetings with them every week for the rest of their lives. And so they just continue to kind of evolve and participate in user groups and things like that are just training sessions to improve their CCPK over time.
Wow, talk about full service, huh? You provide software and the wetware, as they used to call it, you know?
You have to, because if the only thing we care about is our customer success. And if you do, that means you need to be a partner with whatever the challenge is that your customer is facing today.
As much as you need to, yeah.
Yeah, it's kind of fun.
Okay, so I have another question on then, are there certain fundamental capabilities that need to be in place? I mean, as much as you come in with the support, even the kind of skills or people to train the trainer, the kind of thing, what other fundamental capabilities should there be in place before manufacturers even think about deploying digital twins?
Yeah, it's a great question. So I mentioned earlier, and I hope I didn't offend anybody if you don't have an MES. By the way, if you don't have an MES or you have one that needs to be replaced, talk to us. There's a lot of affordable ones that, you don't need a multi-million-dollar MES. But basically, as I mentioned earlier, you need the connectivity part. Remember the middle column of the pillars. And so I just have a drawing here, which is kind of a really high-level representation of a factory. And on the left are the systems you're pretty much going to need. You need the things that are in an MES. And at the end of the day, you need to have everything that's clean data. I thought that was an excellent observation earlier. That represents your product flows, what places can run on what tools. If you're running a factory by sticky notes, this is a problem. But most factories today already have, very clear MES systems. You don't need recipe download, but you certainly need very clear recipe understanding and information and tool information. It's extremely helpful to have tool state data. We talked about that. That's largely what used to be called EI data or equipment interface data. And it really just means, do I know if my tool is up, if it's down, and what it's running and what process it's running. You don't have to have recipe download. Many factories do, but you don't need that to do a smart factory. That's more of a quality initiative, and we support it and suggest it. But you really just have to have your data well managed, and then effectively us or anybody else who's going to do a digital twin come in and connect to all the sources. That's the value of bringing in a third party, is they have the ability, it's called ETL, which is an acronym for extract, transfer, and load, to connect to all these different systems and aggregate it into one smart digital twin. So then you don't need to replace or eliminate any of your existing investment over the last 25 years. You basically put a smart layer on top of your existing infrastructure. So I would say the main thing you do need is access to a good MES, and you need tool state. And I mentioned earlier today, it's very, very helpful to have location tracking, because if you just think about it, you're creating a model and a simulation that has to be real time, and you're literally rescheduling the factory every roughly 3 minutes, which means you better know where everything is. And so that is something that is probably the most common gap, is that many legacy factories do not have location tracking. The good thing is it's probably the cheapest thing available today. And so that's one of the first things that we could help people do. But yes, and then
yeah, it sounds like visibility is key then, right? This panopticon view of everything that you have going in the organization, regardless of where they are, across different repositories of data. You need to have that visibility all across it, right?
Yeah, so you're absolutely right. So first of all, there's, like everything in life, every digital twin isn't equivalent. And a basic digital twin, when you start with a legacy factory, may not include, for instance, all the maintenance information or all the FTC if they don't have FTC. The power of a digital twin is you can add on to it. You can add capabilities, you can add more data, you can add more information. And so, but you are absolutely correct that, it's effectively a holistic, sucking in of every single thing about a factory operationally, and then using all of that to make intelligent real-time decisions. And that's the thing that is so transformative about smart manufacturing, quite frankly.
That's cool. Well, I'm afraid we're getting close to time, so I have to wrap up here. But thank you, John, so much for sharing all these information with us. So for our audience, you may have questions that you were too shy to ask John, but don't worry, you still have a chance to do so by joining our Interchange community platform to post questions and comments, interact with other participants, and also join the discussion forums. So information on joining Interchange is shown on the chat room. There's a link there, and in an email that you received after the session today. So do take a minute to provide some feedback on this session and share your ideas on future topics with us. Again, a link to the recording of today's webinar will be posted also on the ITAP Connect website. So once again, thank you everyone for joining us, and we look forward to seeing you at Interchange at future episodes of ITAP Connect.